Hi, it's Liz Sneddon. Let's have a look at some more examples of discrete random variables. So just a reminder, these are our two formula that will be given on our formula sheet. So we'll come back to the slide here if we need them. So here's our example. So we have some random variable x with a mean of 20 and a variance of 6. So I'm just going to write that up the top here and say, right, my expected value of x, because that's the same as our mean, the expected value is 20, and the variance of x is 6. Okay, and now we need to do some calculations. So we want to find the expected value of 2x. So let me just go back to our formula. If I had a constant in front of the x variable, then I need to multiply that by the expected value. So what I'm going to have here is that's going to be the same as 2 times the expected value of x. So my expected value of x, I can see at the top, is 20. So 2 times 20 gives me an expected value for 2x of 40. Now we want to find the standard deviation of 2x. So looking at our variance formula, if I've got a constant value, then for the variance I need to square that and multiply by the variance. So let's have a look. So we've got a variance there of 6. So I'm just going to do a little bit on the side here. If I want the variance of 2x, then the formula says take that coefficient of 2 and square it, and then multiply that by the variance of x. So I'm going to do 2 squared, which is 4, and multiply that by the variance of x, which is 6, and that's going to give me a variance of 24. Now to find the standard deviation, I need to take the square root of the variance. So square root of the variance of 2x is going to be equal to the square root of 24, and I'm actually just going to leave that as the square root of 24. What I haven't got on the slide here, I just realised there's the other formula that I was just using that says the variance of x is equal to the standard deviation squared. So that means if I want to find the standard deviation, then I take the square root of the variance. So that's just to inform you. Okay, so that's that one. Let's have a look now at the next one. So the next equation is we want to find the expected value of x take away 3. So I'm just subtracting 3 from this expression. So according to my formula, let's look and see what we do. If we're adding or subtracting a constant amount, then I'm just going to add or subtract a constant amount to the expected value. So that's what we want to do there. So this is going to be the same as the expected value of x take away 3. And my expected value of x is 20, and 20 minus 3 is 17. Now we want to find the standard deviation of x minus 3. So let's have a look at the formula for standard deviation. Well, the variance, if we're adding or subtracting a constant, that doesn't change our formula at all. Remember that if I'm adding or subtracting, I'm picking up a distribution and moving it along, but I'm not changing how spread out the distribution is. Okay, so in this case, the standard deviation of x minus 3 is just the same as the standard deviation of x, which we've got that above. We know the variance of x is 6, so that's going to be the square root of 6. And I'm just going to leave my answer this time in that form as well. Okay, the next one is putting both of these types of combinations together. So we've got a multiple of 4 and we're adding 5. So let's have a look. For the expected value, I need to multiply by whatever that value in front is, and I need to add or subtract the constant amount that's being added or subtracted. So here I'm multiplying by 4, so I'm going to say, that question there, by the way, should say expected value. So we're going to do 4 times the expected value of 4x, and then I'm going to add 5 to that. 4 times the expected value of x plus 5. And then I'm going to plug the numbers in. So I know my expected value of x from the top is 20. So 4 times 20 plus 5 gives me a mean of 85. Now for the standard deviation, remember if we're adding or subtracting that plus b, that doesn't change our variance at all. It's only the amount that we're multiplying by as a constant that we have to remember that becomes constant squared. Oh, God. All right, there we go. So I need to find my variance of 4x. Because remember the plus 5, that's not going to change my variance at all. So the variance of 4x is going to be 4 squared times the variance of x. And 4 squared is 16, so 16, and the variance of x is 6. And 16 times 6. Why did I not pick some more nice numbers? Let me get my calculator. 16 times 6 is 96. So that's my variance of 4x is 96. Now to find the standard deviation, I just need to do the square root of that variance. Okay. Oh, God, not again. All right. Let's try a word example problem now. So this is now when I haven't, those previous ones I gave you the actual expression. Now we've got a word problem, we need to work out the expression and then we can use the formula. So what I've got here is the number of pieces of chocolate I eat for a snack has the following distribution. I could have 1, 3, 5 or 7 pieces of chocolate depending at different probabilities. So if each chocolate costs me 50 cents, we need to find the mean, standard deviation and variance of the total cost of the chocolate. Okay, so let's think total cost of the chocolate. Well, my distribution x is the number of pieces of chocolate. So the total distribution is going to be 50 cents times x, the number of pieces. So if I had 1 piece of chocolate, it's 1 times 50 cents. If I have 3 pieces of chocolate, 3 times x. 5 pieces of chocolate, 5 times my 50 cents. Okay, so I'm just going to multiply each of those by 50 cents. So now we need to use our formula and finally start with the mean. So the expected value of x, and we're going to do this the long way. Excuse me while I jump out of this mode. No, and I need to get my lovely calculator. Let's exit the app. Delete. This was a previous question I've done. So I've got 1, 3, 5, 7. And their probability is 0.1, 0.2, 0.3, and 0.4. So let's go and do our one variable. So that gives us our mean there of 5 and our standard deviation of 2. Okay, let me jump into there. So that gives us our mean of 5 and that had a standard deviation of 2. And my new distribution that I need to do is 50 cents times x. So we're going to find the expected value of 0.5x, and I'm going to do, the formula says, going back to a formula, it says what if you've got a constant in front, then just multiply that by the expected value. So we're going to do 0.5 times my expected value, which is 5, and so that would cost me, on average, I expect it's going to cost me $2.50 every time I have a snack. That's approximately how much it would cost me in chocolate each time. Oh, that's a sad number. Never mind. So then let's have a think about what happens with the variation. So going back to our formula, whatever the constant is in front, I'm going to square that and multiply by the variance. So my variance of a half x is equal to a half squared times the variance of x. And my variance of x is, well, I've got my standard deviation is 2. So the variance of x will be the standard deviation squared, which is 4. So I'm going to do a half squared times 4. And I'm definitely going to use my calculator for this at this time of night. And oh, that gives me a nice number of 1. How about that? So that means there's my variance. So now to find my standard deviation of a half x, I'm going to do the square root of 1, which is 1. So so what I have is originally, this is here, that is the mean and standard deviation for the number of pieces of chocolate I ate. What I've gone and calculated is the mean and standard deviation for the total cost of that chocolate. So I've taken that information and I've transformed and created a new variable or a new distribution, which is use that other one, but use additional information. Okay, so there's my distributions. Thanks for watching.